Let's talk about data lakes versus data warehouses. A data lake is like a massive pool of raw data, all kinds of information, from structured records to social media posts and sensor readings. The cool thing is, we don't need to organize it before we put it in, we define the structure as we're using it. It stands in contrast to a data warehouse, which needs everything cleaned and formatted up front like a carefully organized filing cabinet. Data warehouses are great for specific reports, but data lakes provide flexibility for exploring new ideas and finding unexpected insights. Okay team, let's talk about where we're headed with cloud data. Right now, Amazon Web Services, Microsoft Azure, and Google Cloud Platform are the big three when it comes to building data lakes and managing enterprise-level data. AWS is the veteran, it's been around the longest and has a massive selection of tools. Azure really shines if you're already using other Microsoft products. And Google Cloud, they've got some serious strengths in analytics, especially with their BigQuery database, plus they're experts at container technology through Kubernetes. Okay, let's talk about building a modern data lake in the cloud. Think of a data lake as a central repository for all your data, structured, unstructured, you name it. To make this work effectively, we need a solid foundation. First, choose a cloud platform like AWS S3 or Azure Data Lake Storage. They are incredibly scalable and cost-effective. Then, we use tools like Kafka to reliably bring data in from various sources. A key part of the puzzle is metadata management. It's like creating an index for your entire lake so you know where everything is and what it means. Finally, powerful processing engines such as Spark or Hadoop let you transform and analyze the data, turning raw information into valuable insights. Okay, let's talk about getting started with AWS Lake Formation. It's all about making it easier to build and manage a data lake. Think of it as the foundation for storing and analyzing your various data sources. First, you need to create an IAM role that has the right permissions to access your S3 buckets and other services. Then, you'll create a catalog. This acts like a central index for all your data assets. Lake Formation does a lot of the heavy lifting automatically. It crawls through your data sources, figures out what's there, and adds metadata so that everything is searchable. You can also manually add tables if needed. And speaking of use cases, you'll find it's great for things like getting real-time insights, running batch processing jobs, or even making data more accessible to different teams within your organization. Okay, let's talk about Azure Data Lake Storage versus Azure Synapse Analytics. Think of Azure Data Lake Storage as a really big, reliable warehouse where you can store all your data in whatever format it is. It's super durable and cost-effective. Now, Azure Synapse Analytics is more like a powerful engine that combines data warehousing with big data analytics. It's great for running complex queries, processing large volumes of data, and even building machine learning models. The key difference lies in their primary focus. Data Lake Storage holds the raw data, while Synapse uses it to do the heavy lifting in terms of analysis and insights. Let's look at a quick comparison table: storage cost plus compute for adults versus compute-based pricing for Synapse. It really depends on what you're trying to accomplish with your data. Let's talk about Google Cloud Big Lake. It's essentially a way to treat your data lake, that massive collection of raw data in cloud storage, as if it were also a data warehouse. Think of it as a single, unified place where you can query everything, from those initial logs and sensor readings all the way through to polished analytics reports. Big Lake is really great because it lets you evolve your schema, add new columns, or change how data types are defined without having to worry about taking down your systems. And crucially, it gives you incredibly granular control over who can see what. It's built on top of Dataproc Metastore, which helps manage all the metadata and make sure everyone is looking at the same consistent version of the data, regardless of its format. Okay, let's talk about keeping our cloud data lakes from turning into chaotic messes. As we scale up with these platforms, it's vital to implement strong governance. The first step is really understanding what data we have. A good metadata catalog helps enormously here. Then, we need to make sure that the data itself is reliable, setting quality rules and standards. Access control is key too. Only the right people should be looking at sensitive information. Tracking where the data comes from and how it changes data lineage gives us confidence in our insights. Finally, we have to think about when data needs to be kept and when it can be safely removed. It's not a set it and forget it thing. Governance is something that needs constant attention as our data lake grows. Okay, let's talk about keeping your data safe when you're using cloud platforms. It's fantastic that these platforms offer so much power and flexibility, but security needs to be a top priority. We'll cover some key strategies, things like making sure only the right people have access to the right information. Think of it as building layers of protection. Role-based access control allows you to define who can do what with your data, and we'll also discuss encryption, both when sending and storing your data, plus techniques like masking sensitive info to protect privacy. Thus, constant monitoring is essential, along with secure API for all interactions. Let's talk about how to really get the most out of your data. The first thing is establishing clear rules for who owns what data and who can access it. Then, we want to automate as much of the process as possible. Think automatically pulling metadata from all those different places where your data lives. A big part of this is creating a business glossary, so everyone understands what things mean, not just the technical terms. And crucially, we need to track how data moves around its lineage. Finally, don't set it and forget it. You have to continually monitor and update your catalog to make sure it's accurate. Okay, let's talk about how modern businesses are tackling their data challenges. Traditionally, managing data could be a real headache, lots of separate systems, complicated processes, and it was getting expensive to scale. But the good news is that cloud platforms like AWS, Azure, and Google Cloud have completely changed the game. They give us incredibly flexible and affordable computing power and storage. Then we've got data lakes. Think of them as giant reservoirs where you can store your data, no matter what form it takes. And finally, enterprise data management systems are crucial. They are like conductors that ensure everything is governed correctly, secure, and traceable. When you combine these cloud-native solutions, you get huge benefits, faster insights, more agility, and a much simpler way to manage your data all while keeping costs down. Let's talk about bringing all that exciting IoT data into a central place. Think of it, millions of sensors constantly sending information, but raw data scattered across different systems. That's a nightmare to work with. Data lakes are designed to tackle this problem. They act like huge, flexible storage areas where you can dump everything in its original form without needing to worry about how you'll use it later. It's all about flexibility and adapting as your needs change. We'll start by securely collecting data from those devices using cloud services like AWS EOT Core or Azure EOT Hub. Then we store that raw data in a scalable solution like Amazon S3. Finally, we apply tools to clean and transform the data, turning it into something valuable for analysis. Okay, let's talk about getting data into the cloud, specifically how it arrives. We have two main approaches, batch and stream processing. Batch ingestion is like doing a massive data dump. You collect everything at once, usually on a schedule like daily sales reports. It's great for historical analysis and building data warehouses. Think of it as loading up a truck full of data. Now, stream processing is different. Instead of waiting for a big load, it's about capturing data as it happens. Think live website clicks with sensor readings. This is fantastic for real-time decisions like spotting fraud or personalizing recommendations. Services like Kinesis and Event Hubs are designed to handle these constant streams of information. Okay, let's talk about handling all that data swirling around in the cloud. It's a big shift from traditional databases. They were built for structured information, but we're dealing with tons of images, videos, and documents now. Cloud platforms like AWS S3, Azure Blob Storage, and Google Cloud Storage offer incredibly scalable and affordable storage solutions for everything. A key concept here is the data lake. Instead of forcing everything into a rigid structure upfront, a data lake lets you store your structured and unstructured data as is. This gives you huge flexibility to analyze it in different ways later on. Technologies like Hadoop, Spark, and data catalog tools are really important for processing and understanding all this diverse information within the cloud. Okay, let's talk about building reliable data pipelines. We're going to use AWS services, specifically S3 and Glue, to create a system that can handle lots of different types of data. Think of S3 as your central storage space for all the raw information coming in from various sources. AWS Glue acts like a detective, automatically figuring out what kind of data you've got and how it's organized. It builds a catalog so everything is easily searchable. Then we use Glue jobs to clean up the data, transform it into something useful, and load it into specific places for different applications. It's a really efficient way to manage your data and keep things running smoothly, much easier than managing complex ETL processes yourself. Let's talk about lakehouses. They're changing how we think about data management. Think of it like this. You have your flexible data lake, where all the raw information lives, and a traditional data warehouse great for structured reports. Lakehouses bring those two together, offering the best of both worlds. They have a central metadata layer to help you easily find everything, powerful compute engines for quick analysis, and it all works on top of cloud platforms, making it scalable and cost-effective. Ultimately, lakehouses are designed to break down data silos and give everyone faster access to valuable insights. Let's talk about how Delta Lake and Databricks work together. Think of a traditional data lake as a huge collection of files that can be really powerful, but also challenging to manage and ensure data quality. Delta Lake is like adding a layer of intelligence on top of that lake. It brings features like reliable transactions, so you don't accidentally overwrite your data, and schema enforcement, which helps keep everything consistent. Plus, you get versioning, so if something goes wrong, you can always go back to an earlier state. Databricks then provides the environment, a powerful platform for running these processes efficiently in the cloud. Let's talk about keeping our cloud data lakes from turning into chaotic messes. While the flexibility of a data lake is amazing, it means we need to be really smart about data quality. It's a challenge because data comes in all shapes and sizes, often from different sources with varying standards. We can start by profiling the data, understanding things like completeness, accuracy, and consistency. Then, we'll want to clean and transform that data, standardizing formats and fixing errors. Strong data governance policies are vital too, along with keeping track of where our data comes from and what it really means using good metadata management. Okay, let's talk about how organizations are tackling the complexities of managing their data in today's landscape. Many companies now have a mix of systems, some still running on-premise while others utilize public cloud platforms like AWS, Azure, or Google Cloud. This creates an interesting challenge. How do we balance agility with security and cost? A hybrid approach means keeping certain sensitive data within our own infrastructure, while leveraging the power of the cloud for things like analytics and reporting. Then there's multi-cloud, using services from several different cloud providers at once. That gives us even more flexibility and helps prevent us from being tied to a single vendor, but it also requires careful planning and management to ensure everything works smoothly together. Okay, let's talk about getting data into your data lake efficiently. Instead of spending ages manually copying and pasting information, we're using cloud-native tools to automate the whole process. Think about change data capture. It's like a digital mirror that continuously copies changes from your source databases. Serverless functions are also fantastic. They can automatically start pipelines whenever new data arrives. And don't forget about those handy pre-built connectors and API that let you pull information directly from services like Salesforce or Google Analytics straight into your data lake. Let's talk about getting real-time insights. Data lakes are transforming how we analyze information. Instead of waiting for batch reports, businesses are now storing all their data structured, unstructured, everything in a central lake. This allows them to capture streams of data as they happen, using tools like Kafka or Kinesis to grab those events. Then technologies like Spark Streaming and Flink can process that data in real time, transforming it and turning it into actionable intelligence. It's all about speed, agility, and getting the insights you need right when you need them. Okay, let's talk about building a strong foundation for your data in the cloud. As you move to cloud platforms, it's absolutely vital that you don't just dump all your data in one place and hope for the best. We need to create a solid governance framework. That starts with knowing what data you have, so robust data discovery tools are key. Then, we need to make sure that data is reliable and accurate through strong quality management processes. Security is obviously paramount, using access controls appropriately. Finally, it's important to track where your data comes from and how it's being used. Understanding the lineage of your information builds trust. Okay, let's talk about the difference between traditional data warehouses and something new called a data lakehouse. Think of a data warehouse as a very organized filing cabinet. Everything has its place, and you need to know exactly where things are before you can use them. It's great for answering specific questions that you already know the answer to. Now, a data lakehouse is like a much more flexible storage space. It holds all kinds of information in its original form, letting you explore and analyze it in new ways. It combines the strengths of both worlds, offering structured querying alongside powerful analytics tools. Okay, let's talk about keeping your data lake safe. Think of security as having multiple layers like a castle wall. First, we need to control who can access the data using role-based access controls. Then, we encrypt everything both when it's sitting idle and when it's moving around. We also want to protect sensitive information by masking or replacing it with tokens where possible. Finally, constant monitoring and logging are super important so you can spot anything unusual quickly. It's not a one-time thing. Security is something you need to continually invest in. Okay, let's talk about data fabrics. As more companies move their data to the cloud across different platforms like Amazon Web Services, Microsoft Azure, or Google Cloud Platform, it can become a real headache to manage. You end up with information scattered everywhere, making it tough to find what you need and ensuring everyone's playing by the same rules. A data fabric is like a central nervous system for your data. It's designed to connect all those different pieces of information, no matter where they live, and give you a single, clear view. It does this through things like a centralized catalog so you know exactly what data you have, consistent policies around security and privacy, and tools that automatically move and transform the data where it needs to be. Basically, it simplifies your cloud data management and unlocks its full potential. Let's talk about how cloud platforms handle your data over time. We call this data lifecycle management. Think of it as a journey for your information, starting with getting it into the system, transforming it into something useful, making it available to everyone who needs it, and then safely archiving or deleting it when it's no longer needed. It's about balancing cost efficiency with data quality and security, ensuring you always have what you need when you need it, while staying compliant. Okay, let's talk about keeping your cloud storage costs under control. It's a big one. Cloud platforms can be fantastic, but if you aren't careful, those bills can really add up. The good news is there are several things you can do to manage these expenses effectively. First, make sure you aren't over-provisioning your data lake or warehouse. Regularly monitor how much you are using and scale down the size of your instances accordingly. Next, utilize tiered storage. Most cloud providers offer different levels for this storage, from super fast hot storage to slower, more affordable options for archiving older data. Compression and deduplication are also vital. They help reduce the volume of data you actually have to store. Finally, implement lifecycle policies. This allows you to automatically move inactive data to cheaper tiers, ensuring it's not costing you unnecessarily. Okay, let's talk about how we can really supercharge our AI chatbots by connecting them to data lakes. Traditionally, chatbots have worked with neatly organized databases, but a lot of companies are now storing tons of information in these big data lakes. Think logs from servers, social media posts, sensor readings. It's a huge variety. ML workflows, the language we use for building conversational AI, can be used to explore and understand this unstructured data. Basically, we're creating smart data detectives that can answer questions about your entire data lake using natural language. You just ask them what you want to know. Let's talk about data lineage and auditing, especially important when you're working with cloud platforms and large data lakes. Think of it as creating a detailed map showing exactly where your data comes from, what changes it goes through, and where it ends up. This isn't just good practice, it's often legally required to meet regulations like GDPR or CCPA. Lineage helps you quickly spot problems with data quality, and most importantly, it builds trust in the information you're using for your business decisions. Cloud providers offer tools that can automate much of this processing, like AWS Glue Data Catalog and Azure Purview. And a strong metadata management system keeps everything organized and accessible. Let's talk about moving those older, established data warehouses into the cloud and building a modern data lake. First, we need to really understand what we're dealing with. How complex is your existing warehouse? Then, we shift our thinking towards designing something more flexible for the cloud, often using a schema-on-read approach. We'll build pipelines to bring that data in and transform it as needed. It's not just about copying the data, it's about setting up the right tools and processes for managing and securing everything. A phased migration is generally the safest route. Okay, let's talk about ETL and ELT. In the past, we used to do things in a specific order. First extract the data, then clean it up and transform it, truly shaping it before loading it into our data warehouse. That's ETL. But with cloud platforms, especially data lakes, there's now an alternative called ELT. With ELT, we just grab the raw data and load it straight in. Then, once we need it, we apply the transformations within the data lake itself. It's a shift towards being more flexible and agile with how we handle our data. Let's talk about querying your data lake. AWS Athena is a really powerful tool for doing just that. It's essentially a serverless query engine that lets you use standard SQL to access the data stored in Amazon S3 data lake. You don't have to worry about managing any servers or infrastructure, which makes it incredibly easy and scalable. And the best part, you only pay for what you actually scan when running your queries. So, if you've got a lot of raw data sitting in S3, Athena is an excellent way to unlock its insights. Okay, let's talk about Azure Purview, Microsoft's solution for making sense of all that data you've got scattered around. It's essentially a smart tool designed to help you understand, trust, and control your data across the entire company. Purview automatically discovers where your data lives, whether it's in the cloud, on-premise, or somewhere else. And it doesn't just find it, it traces its journey, how it moves through different systems and gets transformed along the way. That traceability is super valuable for compliance and auditing. You can even classify data based on things like privacy sensitivity, making sure you're handling sensitive information correctly. Ultimately, Purview uses a really clever mapping system, a kind of visual graph to show you how all your data assets are connected. Okay, let's talk about keeping your data safe and sound when you're using the cloud. Cloud platforms provide powerful encryption tools, things like encrypting your data while it's stored on their servers, and making sure that all communication between you and the platform is securely locked down with TLS. They also have options for protecting specific pieces of information within databases, like individual columns. But security isn't just about technology, privacy compliance is key too. It means collecting only what you absolutely need, using data only for the purpose you stated, and always getting clear consent from people when required. Think GDPR, CCPA, HIPAA, these are all important regulations to keep in mind as you build your cloud strategy. Okay, let's talk about building a really effective analytics platform. The first thing we want to do is create a central data lake, essentially a place where all your raw data lives, like in Google Cloud Storage. Then BigQuery comes in as the engine. It's a powerful serverless database that lets you query this data directly using SQL. Because BigQuery uses a schema-on-read approach, you don't have to define how the data is structured up front, you do it when you ask questions of the data. We can use Google Dataflow to clean and transform our data before loading it into BigQuery, and then connect BI tools like Looker or Tableau so that anyone in the organization can easily access those insights. Let's talk about keeping a close eye on your data lake. Think of it like this: you've built a massive warehouse, but without monitoring, you don't know if everything is flowing smoothly or if anything is going wrong. We're covering key areas: how to track performance, make sure the data itself is accurate and consistent, and really focus on security. There are some great tools out there that work seamlessly with popular cloud platforms like AWS, Azure, and Google Cloud, as well as some powerful open source options if you need more customization. Okay, let's talk about enterprise master data management moving to the cloud. It's a really powerful shift that brings some huge advantages. Think of it like this: the cloud offers incredible flexibility. As your data grows, or if you need more users accessing your MDM system, it just scales up automatically. Plus, you dramatically cut down on costs because you don't have to worry about maintaining servers and hardware yourself. Finally, having everything in a central location thanks to platforms like AWS Glue or Azure Data Lake Storage helps ensure everyone is working with the same accurate information, which means fewer errors and much better decision making. Let's talk about getting the most out of your cloud investments. When you spread data across different cloud providers like AWS, Azure, and Google Cloud, it can become a real headache to pull everything together for analysis. Federated querying is all about simplifying that process. Imagine having a central hub, a metadata catalog that knows exactly where every piece of data lives in each cloud. Then a query federation engine takes your requests, translates them into the specific language each cloud understands, and runs those queries remotely. It's like magic. You don't need to worry about complex data movement or transformations. You just ask for what you need through a single interface. Okay, so data lakes are awesome because they let us store everything *, but that flexibility can also make managing our data really tricky. Without a solid plan, as data comes in from different places with different formats, things can quickly get messy. Queries might fail, reports could be wrong, and our data quality suffers. The good news is there are ways to tackle this. First, we need to keep track of everything using a central metadata catalog. Think of it like the library card catalog for your data lake. Then, we'll want to learn some schema evolution techniques, which are basically how we handle changes to our data structures without breaking things. Techniques like forward and backward evolution let us add or remove columns as needed, and schema versioning lets us roll back if something goes wrong. Finally, using tools like Avro and Parquet with schemas code can really help us stay organized and consistent. Let's talk about how we can ditch the old ETL headaches. For years, companies have struggled with these time-consuming processes that move data from where it lives to a central warehouse. But there's a better way: zero ETL architectures. Instead of transforming data before loading it into a data lake, which is like trying to force a square peg in a round hole, we let the data land as it is. This means less delay, fewer errors, and more flexibility. Data lakes are central repositories that hold all kinds of information: structured, semi-structured, even unstructured. And with schema on read, we transform the data when we need to use it, giving us incredible control. Cloud platforms like AWS S3, Azure, and Google Cloud offer the scalable storage and processing power this approach needs. It's a move towards agility and truly harnessing the potential of your data. Okay, let's talk about data mesh. By 2025, we're seeing a huge shift in how big companies are handling their data. Instead of one giant central data lake which can become a bottleneck, the trend is moving towards something called data mesh. Think of it like this: each business domain like marketing, sales, or finance takes full ownership of their data. They build independent data products, making sure they're easy to find, reliable, and secure. It's not about everyone doing things their own way. There are shared rules and standards, a federated governance model that keep everything working together seamlessly. Okay, let's talk about keeping your data lake costs under control. Data lakes are fantastic, but they can get expensive if you aren't careful. The key is to be proactive and constantly monitor your spending. We want to make sure we're not overpaying for resources. A lot of that comes down to right-sizing the instances you're using. Think about what data you're actually accessing frequently versus less often, and then choose the most appropriate instance type. Also, don't forget storage tiering. Moving older, rarely used data to cheaper storage options can make a huge difference. And of course, we need to be smart about compressing our data and encrypting it, both things that reduce the amount of storage needed, which translates to lower costs. Finally, efficient queries are vital. Spending less time processing data equals reduced expenses. Fortunately, there are some really helpful tools out there like AWS Cost Explorer or Azure Cost Management Advisor that can give you detailed insights into your cloud spending and offer recommendations for optimization. Okay, let's talk about building pipelines that don't just batch data but react to it instantly. We're looking at how we can get information as soon as it arrives. Think sensors sending readings or users posting on social media. The first step is ingesting this data from various sources using tools like Kafka or Kinesis. Then we use a streaming ETL process to do some initial cleaning and shaping. Next, real-time processing engines, things like Flink or Spark Streaming, crunch the numbers and apply more sophisticated logic. Finally, all that transformed data lands in a data lake, ready for analysis and visualization. It's about moving from scheduled updates to continuous insights. Okay, let's talk about serverless data pipelines. They are a really exciting development in how we move and process our data. Essentially, you don't have to manage any servers yourself. This means less work for your IT team, and it can be much cheaper because you only pay when the pipeline is actually running. While there are some potential downsides like being tied to a specific cloud provider and sometimes having debugging challenges, they are really well suited for things like real-time analytics. Think processing data as it comes in or handling huge volumes of data from IoT devices, and even simplifying log analysis. Okay, let's talk about Google Dataflow. Essentially, it's a powerful tool that helps you process information asterisk as asterisk it arrives, not just when you batch it up. Think of it like a super efficient conveyor belt for data. It automatically handles scaling, meaning if your data volume suddenly spikes, it adapts without you having to lift a finger. And because it's built on Apache Beam, you can actually reuse the same code across different platforms too. It's all about getting real-time insights from streaming data. Let's talk about Snowflake. It's a really innovative platform that combines the best of both worlds, a flexible data lake and a powerful analytics warehouse. Think of it like this: you can store all your different types of data, from structured spreadsheets to raw logs, in one place. Then, when you need to analyze it, Snowflake's incredibly fast query engine kicks in. What's really cool is that Snowflake lets you scale up or down your computing power and storage separately, which means you only pay for what you use, making it a smart choice for many businesses. Okay, so we're talking about getting your data operations ready for the cloud. It's not enough to just dump everything up there. You need a structured way to manage it. We're focusing on data ops, basically treating your data pipelines and infrastructure like software. That means things like automating how you set up your cloud environments with the infrastructure as code. Then we need continuous integration and delivery for those pipelines, so testing and updates happen smoothly. Monitoring data quality is critical, catching issues asterisk before asterisk they impact business decisions. Finally, strong metadata management and security baked into the process ensure trust and prevent risks. Okay, let's talk about keeping your data healthy in the cloud. Data drift is a really important concept. Essentially, it's when the characteristics of your data change over time. Think of it like this: your initial training data might look great, but as your business grows and you start collecting new information, the patterns within that data can shift. This impacts everything from the accuracy of your models to how consistent your reports are. We'll cover some key techniques for spotting this drift, things like statistical distance measures and comparing profiles over time. And don't forget, many cloud platforms offer built-in monitoring tools to help you stay on top of it. Let's talk about getting your data where it needs to be. Many companies have information stuck in separate systems. It's like having puzzle pieces scattered everywhere. That makes it hard to get a clear picture of what's happening. Thankfully, there are some fantastic tools that can help us connect those dots automatically. Fivetran, Stitch Data, and Tailwind in the cloud are all popular choices for building data pipelines. They take care of much of the heavy lifting so you don't have to code everything yourself. Fivetran is known for its huge range of pre-built connectors, making it great if you've got a lot of different sources. Stitch Data is really user-friendly and good for simpler integrations. And Tailwind in the cloud offers more complex processing capabilities with lots of flexibility. Let's talk about getting the most out of your data in a hybrid environment. Data virtualization is all about creating smart, logical views of your information rather than physically moving it around. It's like having a single pane of glass to access everything from your on-premises systems and your public cloud environment. First, you'll need to map out exactly where your data lives, what kinds of files, databases, or applications are involved, and how quickly people need to get their hands on it. Then, you can choose a virtualization platform that plays well with your chosen clouds. Next, you'll build those logical views. Think of them as simplified interfaces and expose them through APIs so users can easily access the data they need. Finally, it's all about deploying this solution across both your on-premises setup and your cloud infrastructure, ensuring everything stays secure. Let's talk about how AI is tackling a common challenge with data lakes, making sense of all that raw information. Data lakes can be amazing resources, but if you don't have a good way to organize and understand the data within them, they quickly turn into data swamps. The good news is that artificial intelligence is changing this. AI algorithms are now able to automatically figure out what kind of data you're dealing with, whether it's structured like tables or unstructured like text. They can also add helpful tags and descriptions based on the content itself, making it much easier to find exactly what you need. And best of all, these catalogs aren't static, they constantly update as new data comes in, so you always have a current picture of your lake's contents. Okay, so let's talk about building data pipelines that aren't just efficient, they also meet all the regulatory requirements. It's really important to understand where your data is coming from, how it's being changed as it moves through the pipeline, and where it ends up. Cloud platforms offer amazing tools for tracking this, called data lineage. Think of it like a detailed roadmap of your data. You also need to make sure only the right people have access to sensitive information. Strong access controls are key. And don't forget about security. Encrypting your data at rest and during transit is vital. Finally, robust logging and auditing allow you to track everything that's happening in the pipeline, making it much easier to investigate any issues or demonstrate compliance to auditors. Okay, let's talk about how we can get data into our systems faster and make it more adaptable. Traditional methods often involve huge batch processes that take a long time to run. That's where event-driven architectures come in. They break down the process by creating loose connections between different parts of your system. It's like a chain reaction. Each piece reacts only when an event occurs, letting them scale and handle changing data volumes much more easily. Think about a website. Every time someone views a product, adds something to their cart, or makes a purchase, it's an event. An event-driven system can react instantly, suggesting related items, alerting inventory managers, or sending out targeted promotions. Let's talk about how we can tackle complex relationships within our data lakes. Traditionally, relational databases aren't great at handling these intricate connections between different pieces of information. But with cloud data lakes like AWS S3 and Azure Data Lake Storage, we have massive scalability. Now, graph databases like Neo4j or DB are a fantastic solution. They're designed specifically to shine when relationships matter. Think social networks, supply chains, or even customer journeys. Essentially, we store our raw data in a lake, then extract and transform it, loading it into the graph database. Change data capture keeps things synchronized, and you can use query languages like Cypher to dive deep into those connections and uncover valuable insights, often by combining the best of both worlds. Let's talk about making your data lakes super reliable, because a single region outage can seriously impact your business. The good news is we can build high availability across multiple locations. That means automatically copying data to different areas, like using services that mirror your data in another cloud zone or even another country. We'll want an architecture, either where one region handles the primary work and a backup steps in if needed, or where both regions are actively working. And don't forget the metadata. You need a central catalog to easily find and understand all your data, no matter which region it's stored in. Finally, keep a close eye on everything with robust monitoring and alerts, because you want to know immediately if something goes wrong. Let's talk about how we can ditch those clunky legacy ETL processes and move to the cloud. Traditionally, these systems could be a huge bottleneck. They're hard to scale, require a ton of maintenance, and often create data silos across your organization. But moving to the cloud opens up amazing possibilities. Think big, scalable data lakes where you can store all your raw information, combined with powerful cloud data warehouses for structured analysis. And best of all, serverless ETL services are taking over, automating these workflows and reducing the operational burden. Okay, let's talk about securing your data in the cloud. As you scale with platforms like AWS, Azure, and Google Cloud, managing who can see what becomes really important. Role-based access control, or RBAC, is a vital strategy for this. Essentially, we define roles within our organization, like data analyst or data engineer, and then grant specific data access permissions based on those roles. It's not about giving everyone blanket access, it's about tailoring access to the job function. Your cloud provider will have built-in tools for this. Take advantage of them. And remember, security isn't a one-time thing. Regular audits of your roles and permissions are key. Let's talk about how these data storage approaches compare. A traditional data warehouse is like a really well-organized filing cabinet. It's great for structured data and reporting, but can be rigid. Then we have a data lake, which is more of a massive storage room. You store everything in its raw form and decide how to interpret it later. Finally, the lakehouse brings together the best features of both, giving you flexibility while still offering the performance of a data warehouse. Think about your specific needs. Are you focused on historical reporting or exploring new datasets? That'll help you choose the right solution. Okay, let's talk about how we handle time series data within an enterprise data lake. Time series is becoming huge. Think of all the sensors in factories, the metrics coming from apps, or even financial trades. Traditional databases just aren't built for this type of data. Data lakes offer a solution. They provide flexibility with something called schema on read, which means we don't have to define everything up front. We can adjust as needed. Then, partitioning and bucketing by time is super important for performance. It makes querying much faster. Finally, using efficient storage formats like Parquet or ORC really helps when analyzing the data. Let's talk about building connections, specifically data connections. We're going to focus on how to establish effective data sharing hubs that bring together your team and external partners. It starts with the cloud. Platforms like AWS, Azure, and GCP provide the scalable infrastructure you need. Then we want a central place for all our data, a data lake, so everyone has access to the same information in a consistent format. And critically, an enterprise data management system helps us manage the data, ensuring it's accurate, secure, and compliant. Think of it as a well-organized center where partners can easily find what they need and use it securely. Let's talk about how we can keep our data lakes clean and trustworthy. Traditional data lakes sometimes end up as messy data swamps, making it really hard to understand what's going on or trust the information. The solution is using immutable storage, which is like Git for your data. You never actually change a file, instead creating new versions every time something changes. Cloud platforms offer built-in object versioning that automatically tracks all these changes. This provides great benefits, including easier auditing and compliance, the ability to roll back to previous states if needed, and access to historical analysis without having to worry about multiple copies of data. Okay, let's talk about getting data asterisk into asterisk your cloud data lake efficiently. Traditionally, loading data often involved complex and time-consuming ETL processes. Think of it like manually reformatting everything every time things change. But with metadata-driven frameworks, we've shifted to a much smarter approach. Essentially, instead of telling the system exactly how to transform the data, we feed it information about the data itself, its type, where it came from, and what rules apply. This allows automated pipelines to adapt dynamically as new sources are added or requirements evolve. We start with a central catalog that defines everything about our data, then build pipelines that read data based on this metadata, automatically transforming it as needed. Okay, let's talk about getting your machine learning models out into the real world. Traditionally, building a model was just one step, but now you need to make sure it actually works and can handle lots of data. That's where cloud data lakes come in. They are huge, flexible storage spaces that allow you to dump all sorts of different types of data, structured, unstructured, everything. Cloud platforms like AWS S3, Azure Data Lake Storage, and Google Cloud Storage offer this scalable storage. And a key part of the process is an enterprise data management system. It's essentially a guardrail ensuring data quality, security, and that you can trace where all your information comes from. Okay, let's talk about getting data moving smoothly between different cloud environments. It can be tricky because each provider has its own way of doing things. Think AWS, Azure, or Google Cloud. That means lots of setup and potential problems if you're not careful. Luckily, tools like Apache Airflow and Prefect help a lot. Airflow is a really powerful workflow manager that lets you build complex data pipelines visually using something called DAG. And Prefect, it's newer and designed to be more flexible, particularly when things change unexpectedly. It's great for reactive workflows. We've put together a quick comparison of the two. Think about what's most important for your team. Okay, let's talk about keeping our data safe in the cloud, especially when dealing with sensitive stuff like financial records or healthcare information. It's fantastic that the cloud gives us so much flexibility and power, but we absolutely need to be mindful of regulations. Think HIPAA for health data, GDPR for privacy, and PCI DSS if you're handling credit card detail. They each have strict rules about how data needs to be protected. It's also important to know where data is actually stored. Some laws require it to stay within a specific country. And of course, controlling who can access that data is super crucial. Fortunately, cloud providers are offering tools like encryption and masking techniques to help us meet those requirements, logging everything closely and making sure access is tightly controlled. Okay, let's talk about how AI is revolutionizing the way we monitor our data lakes. Think of a data lake as this huge, sprawling ocean filled with all sorts of information: sales figures, website traffic, customer feedback, you name it. Traditionally, keeping an eye on everything and spotting problems has been really tough. But now AI can step in to help. It learns what's normal within the lake by analyzing past data, so when something unexpected pops up, like a sudden spike in errors or unusual activity, the system immediately alerts us. It's like having a super smart detective constantly scanning for anything out of place. Let's talk about getting that valuable data from your SaaS tools like Salesforce or Marketo into a central place. The challenge is often these systems are built in isolation, making it hard to get a full picture of what's happening across the business. Data lakes solve this by giving you one spot to store all types of information, structured and unstructured alike. Essentially, we extract data from those SaaS platforms, clean it up to make sure it's consistent, and then load it into our data lake for easier analysis. It's about bringing everything together. Okay, let's talk about unlocking the full potential of your cloud data. We're diving into open metadata standards, essentially a common language for describing all those different datasets floating around in the cloud. Instead of each platform using its own complicated system, we're building a shared vocabulary. This means it becomes much easier to find what you need, enforce good governance practices, and really understand where your data is coming from and how it's being transformed. We'll look at some popular standards like DataHub, Apache Atlas, and Marquez tools that are making this whole thing work together seamlessly. And don't worry, we'll cover what comes next as we move forward. Let's talk about the challenges of managing data access when you're spread out across multiple cloud providers. It's incredibly common to find that each platform has its own way of handling security, which can quickly become a tangled mess. Duplicating policies and keeping everything consistent is a huge time sink, and it also opens up opportunities for mistakes, things like misconfigured settings or inconsistent access rules. The good news is there's a better approach: establishing a central governance framework. This means creating one set of policies that you can apply consistently across all your clouds. Using a back or attribute-based access control allows us to base permissions on who's requesting access, what they need access **to**, and even where they are trying to get it from. And federated identity ensures everyone uses the same login credentials everywhere. Let's talk about getting your data moving smoothly with Azure Synapse Pipelines. They are a really effective tool for automating and managing all those complex data workflows you've got going on, especially when dealing with different cloud environments or even on-premises systems. Synapse pipelines aren't just about copying data, they help ensure that the data is reliable, consistent, and arrives exactly when it's needed. Think of them as your central control panel for everything related to your enterprise data, from pulling information from various sources, transforming it into a usable format, and then delivering it efficiently. They offer strong integration with services like data lake storage, SQL databases, and even Spark for more advanced transformations. Okay, let's talk about how we can store our data effectively in a data lake. The key is understanding that different formats are better suited for different tasks. Parquet is fantastic when you're running complex analytics because it only reads the columns actually needed. Azure handles changes to your data structure really well. It's great if things evolve over time. JSON is easy to read and understand, perfect for getting data in initially, but it can be slow for big queries. Finally, ORC offers a good balance between speed and storage efficiency, especially when working with Hive. Okay, let's talk about protecting your data lake investments. Traditional backup methods just aren't built for the scale and variety of a data lake. Think about it: you've got everything from images to logs to sensor readings, all in different formats. Cloud-native solutions like replicating your object storage across regions, creating snapshots, and using immutable backups offer a much more efficient and reliable approach. It's not just about backing up the data, it's about ensuring its integrity and availability when you need it most. Keep cost, compliance, and retention policies in mind as you plan your strategy. Okay, let's talk about how we store and use data. First up, we have operational data stores, or ODDs. These are like real-time snapshots of what's happening in our business. Think sales figures updating as they happen. They are built for immediate reporting. Next, we have data lakes, which are essentially giant storage pools that can hold all kinds of data, structured and unstructured, from a huge range of sources. They're really flexible because you define the structure when you need to analyze the data. Finally, there are data warehouses. These are more traditional and designed for business intelligence, using cleaned and organized data to spot trends over time. The key difference is that ODS are for immediate operations, data lakes offer flexibility, and data warehouses focus on structured reporting. Does that make sense? Let's talk about how cloud platforms are reshaping the way we handle data. For years, companies were stuck with separate databases, making it really hard to get a complete picture. Cloud providers like AWS, Azure, and Google offer incredible infrastructure. They're essentially giant computers that can hold tons of information. Alongside this comes the concept of a data lake. Think of it as one massive storage space for all sorts of data types, from images to spreadsheets. Then there are enterprise data management systems, which are getting smarter and working together to pull everything into one place and make sure it's managed properly. Finally, we're seeing the rise of unified analytics platforms. These clever systems combine all this data in real time, letting businesses react quickly to changes and deliver more personalized experiences. Okay, let's talk about building data exchange marketplaces, essentially creating a place where companies can easily share their data with others. It's all about connecting those who have valuable data sets with those who need them. We're using cloud platforms like AWS, Azure, and GCP to host these marketplaces because they provide the necessary infrastructure. Data lakes are crucial here. They're the big storage spaces where all that data lives, and a strong enterprise data management system keeps everything organized, secure, and trustworthy. Think of it as a digital marketplace for information. Okay, let's talk about how these table formats stack up against each other. We've got Delta Lake, Apache Iceberg, and Hudi, all popular choices for managing data in your data lake. Delta Lake is great if you want a really simple way to ensure transactions are reliable and you can easily go back in time to previous versions of your data. Iceberg offers strong metadata management, which helps with large-scale datasets and efficient querying. And Hudi shines when dealing with constantly changing streaming data. It's built for performance in those scenarios. Thinking about what kind of workload you have will help you choose the best fit. Let's talk about keeping your data safe and sound, especially as it grows. Traditional archiving can be a real headache: expensive hardware, complex processes, and limited scalability. The good news is that cloud platforms have completely changed the game. We're looking at strategies like tiered storage, where you move frequently used data to faster, more reliable areas while automatically moving older data to cheaper archive tiers. Lifecycle management policies are key here. They're basically automated rules that say move this data after 6 months or delete this data after a year. And don't forget about your data lake. It can be a fantastic central hub for archiving and governing all your information, combined with services like AWS Glacier or Azure Archive Storage. It's really about finding the right balance between cost, accessibility, and compliance. Okay, let's talk about bringing data from the edge into our cloud data lakes. Think of all those sensors and IoT devices generating constant streams of information at the asterisk of data. Instead of sending everything raw to the central lake, we take a smarter approach. We first process some of that data right at the source on the edge itself. This means filtering out irrelevant information, summarizing what's important, and even detecting anomalies. Then only the key insights are securely sent to the cloud where our centralized data lake resides. It's like pre-digesting the data before sending it along. This drastically reduces bandwidth needs, speeds up processing times, boosts security, and ultimately saves us money. Pretty neat, right? Let's talk about turning raw data into something useful. Data lakes are fantastic for storing all kinds of information, but they are only truly valuable when you can see what's going on instantly. We're focusing today on building real-time dashboards that pull directly from your data lake queries. Think of it like having a live window into your business operations. We'll cover the key ingredients: a powerful query engine, a dashboarding tool, and sometimes even some streaming capabilities to keep those visuals constantly updating. Ultimately, these dashboards give you the power to react quickly and make informed decisions based on what's actually happening. Let's talk about Data Mesh and Data Fabric. They are both trying to make data easier to use in the cloud, but they have very different ideas about how that works. Data Mesh is like giving each individual team who creates data, like marketing or sales, complete control over their data. They treat it as a product and own its quality and availability. Think of it as a distributed approach. On the other hand, Data Fabric takes a more centralized view. It's like building a smart network that connects all your data sources together, making sure everything is properly governed and flows smoothly. It's about orchestration, bringing everything under one umbrella. Essentially, Mesh focuses on who owns the data, while Fabric focuses on how it's managed. Thank you for watching.